In this video, we're going to be working through a sex-linked Punnett square problem. The first thing that we do is we always establish the key. So if you are a female, your sex chromosomes are XX, and if you are a male, your sex chromosomes are XY. And remember, these pair of sex chromosomes, these are on chromosome number 23. And the most important part about these chromosomes on pair 23 is that they will determine which gender that you are. Besides the sex chromosomes, we're also going to carry traits on these. And remember that a hemophiliac is an individual or someone that has a problem clotting or stopping their blood from bleeding. So if you get a cut, hemophiliacs have a hard time stopping that bleeding. So we would represent this with the lowercase h, and if you have an uppercase h, this means that you would have normal blood and you would be able to clot it, or you could stop bleeding on your own. So knowing this, we are going to cross the parents together. We're always going to cross dad with mom. Since dad is a male, his sex chromosomes are going to be XY, and since mom is a female, her sex chromosomes are going to be XX. The problem states that we are going to cross a hemophiliac man and a heterozygous normal woman. If a man has hemophilia, this means that he is going to carry this little h on his X chromosome. We don't ever carry any traits on the Y chromosome, so leave it alone. The XX chromosomes, it says that mom is heterozygous, which means that she will have two different size letters carried on her sex chromosomes. Heterozygous always means different. And in this case, heterozygous means two different size letters. Go ahead and put the sex chromosomes in the gametes. Mom has XX, she is a female, and dad has XY since he is a male. Carry over the trait, so this little h will go above this X chromosome, this capital H, and this lowercase h will also go above those sex chromosomes. Join the sex chromosomes first together in the box. Bring down this X, bring over this X. Bring down this X, and bring over this X. Bring down this X, bring over this Y. Bring down this X, and bring over this Y. Lastly, we're going to then bring down the traits. So we have a capital H and a lowercase. The capital always has to be written first. We have two lowercase h's, so we will write those on each sex chromosome. A capital H is on this X chromosome, and then a lowercase h is written on this sex /X chromosome. Remember that we have to look at females and males differently. So for the genotype, first start with the females. Well, we can see that we have a different combination for each of these, so we're going to write out each combination that we received and cross it out as you go. You are going to write 1 XX, big H, little h, and you have 1 XX, little h combination. Looking at the males, these two boxes are not the same, even though they are both males. This is a capital H, this is a lowercase. So we say that this is 1 XY with a capital H, and we have 1 XY with a lowercase h. The phenotype, cover up one of the genders and interpret the other boxes above it. So I covered up the males, let's just look at the females. I can see that this female, because she is XX, has at least 1 capital H, making her normal, and this female has 2 lowercase h's, making her a hemophiliac. So the way that we're going to write out our phenotype, you will tell me that 1 of these boxes is a normal female, and this is what this first box states. my second female box, I've got one hemophiliac female, and that's again what this box states. Cover up these two boxes and look at the males. Both of these are males. One is going to be normal blood and one is going to be a hemophiliac. So the way that we write it is one normal male. Again, that's what this box says right here. And the last box, we would have one male that is going to be a hemophiliac. Okay. And this is how we write our phenotype. So what this says is that when these two parents come together and when they have one offspring, there's always a 50-50 shot of either having a male or a female, so having either a boy or a girl. And what this is going to say is that if this couple has one boy, there's also a 50-50 shot of having normal blood or possibly having a hemophiliac blooded son or male. If this couple were to have a female, this says as well that there's a 50-50 shot of either having a normal blooded female or daughter and having a hemophiliac female or daughter. Hopefully this video helped you. If you have any questions, please let your teacher know. Thanks for watching.